Imagine you're running an app and it suddenly becomes super popular. Maybe it just got featured in a viral TikTok, or someone famous tweeted about it. Either way, you're loving the attention until user requests start pouring in like you're giving away free pizza, and your poor single server is waving a white flag. This leads to slow response times, downtime, and angry users. A perfect storm for negative reviews is inevitable. What to do in this situation? Well, you can scale vertically by upgrading your server, by basically throwing money at the problem and pumping up your server until it's beefy enough to compete in a bodybuilding competition against Terminators. But let's be real, upgrading isn't cheap, and there's a certain limit to how much muscle you can pack into one server. Instead, horizontal scaling is your second, but often better choice, as you can add more servers to share the load. And that's where the load balancer comes into play. Think of it as a friendly store manager in a busy grocery store who directs you to the shortest line. By distributing traffic evenly across all cashiers, the load balancer keeps everything running smoothly, preventing long waits and cranky customers. There are several balancing algorithms a load balancer can use. The first and simplest algorithm is called the round robin, where everyone gets served in order one at a time, and it won't matter how much or how little they plan to buy in your supermarket. Server 1, Server 2, Server 3, and back to Server 1. The downside is that it simply doesn't check if one server is still busy with the current request, which can cause overload on a particular server. The least connections algorithm, on the other hand, is a bit smarter. It constantly checks which line has the fewest number of customers and says, Server 3, you look like you could handle another customer. This keeps things more balanced, especially when one of your users is ordering the digital equivalent of 5 six-packs, a massive video upload, for example. The next goes IP hash, which is perfect for anyone who can never decide which line they should go to. With this algorithm, your request is always sent to the same server based on your IP address, ensuring that there's always a place in a line for you, handy for maintaining session persistence. And there are some other noteworthy algorithms, but maybe we'll talk about them next time. This all sounds amazing, but do we have to build this from scratch? Thank God no. Cloud providers have already done the hard work, so you can enjoy yourself by adding new features and fixing bugs. AWS Elastic Load Balancer automatically distributes traffic across multiple EC2 instances, containers, and even microservices. It supports scaling based on demand and integrates with other AWS services like autoscaling. Google Cloud Load Balancing offers global and regional load balancing, automatically distributing traffic based on proximity, traffic patterns, and server availability. Azure Load Balancer balances traffic across your virtual machines and integrates with Azure's autoscaling capabilities to adjust resources as traffic changes. Best of all, these cloud services include automatic failover, so if one server decides it's time for a nap, another steps in without you having to lift a finger. And there you have it. Load balancing made simple. If this helped, hit that like button, share with a friend who's sweating over server management, and subscribe for more system design tips. See you in the next video.